Hello everyone. So here we are back again with another lecture on 4-bar and slider crank mechanism analysis by relative velocity method. Okay. So moving on to the topic, here you have seen the 4-bar mechanism analysis by relative velocity method. Okay. So 4-bar mechanism is given below in the diagram, having angular velocity omega radian per second in the clockwise direction. Okay, so here you have seen the 4-bar mechanism. Okay, as we have already discussed about 4-bar mechanism. So here the fixed link 1,4 is the fixed link, this 1,2 is the crank with angular velocity omega radian per second having clockwise direction. Okay, 2,3 is the coupler or the connecting rod, 3,4 is the slider. Okay, so velocity of the point 3 relative to 1 is equal to velocity of point 3 relative to velocity of point 2 plus velocity of point 2 relative to velocity of point 1. Okay, so here in this diagram you can refer to it. Okay, so here you have seen the expression, that is V31 is equal to V32 plus V21. Okay, so the velocity of point 3 relative to 1 will be equal to velocity of point 3 relative to 4, as point 1 and point 4 both are fixed. Okay, so here you can see that point 1, this one, and this one, 4, both are being fixed. Okay, so it will be V34 is equal to V32 plus V21. Okay, so here it will be V21 is equal to omega into 1 and 2, which is perpendicular to 1, 2. Okay, similarly here you can see V32 is unknown in magnitude, but it will be perpendicular to link 2, 3. Okay, V34 is unknown in magnitude, but it will be perpendicular to link 4, 3. So here you can see the velocity diagram. Okay, so here this is the fixed point 1, 4. Okay, from here it is the point 2 here, so it is the velocity of 2 with respect to 1. Okay, how to take, as we have already discussed in our previous lectures, how to draw the velocity and diagrams. Okay, so here you can see the velocity for point 3, velocity of 3 with respect to point 2, and here you can see this is the, since this is the fixed point, velocity of 3 with respect to point 4. Okay, so angular velocity of links, here you can see velocity of 3 relative to 2, V32, link 3 moves in anti-clockwise about 2 here. Okay, so link 3, this one, it moves in anti-clockwise about point 2. Okay, so the expression comes as V32 is equal to omega 32 into 2, 3. Okay, next B, you can see velocity of link 3, 4. Okay, so angular velocity of link 3 relative to 4 is in clockwise direction. So slider crank mechanism analysis by relative velocity method. Next, so here angular velocity of link OA is given omega, and velocity of point A can be given by VA is equal to omega into OA, which is equal to VAO in the clockwise direction about O. Okay, VA is perpendicular to OA, so we know the direction and magnitude of VA. The velocity of slider B is along OB. The configuration and velocity diagram for this problem is given in the next slide. Okay, so here you can see the velocity diagram of slider crank mechanism. This is the slider crank mechanism, and this is the velocity diagram of the slider crank mechanism. Okay, so here you can see this is the fixed point. Okay, this is the point A, and this is the crank which rotates in the clockwise direction. AC, it is the connecting rod or the coupler, and here it is the point C, this is the slider. Okay, so the steps that have been written here, we will just go through it, and it will be very much clear how to draw the velocity diagram stepwise. Okay, so for this slider crank mechanism, for drawing the velocity diagram, first step 1, we have to take any point O, okay, and draw vector OA. Which vector? This one. Draw vector OA is equal to omega into OA. Okay, so omega into OA is equal to VAO, which is perpendicular to OA. Okay, so this one OA in some suitable scale as shown in the velocity diagram. Okay, so in some suitable scale, we take any point O and draw vector OA such that OA is equal to omega into OA is equal to VAO. Okay, which is perpendicular to OA in some suitable scale. Next, step 2, the velocity of point B with respect to A, that is VBA, is perpendicular to AB. So from A, draw a vector AB perpendicular to line AB. So here you can see in this diagram. Okay, next, the velocity of slider B is along the line of stroke OB. From O, draw a line parallel to OB which will intersect vector AB at B. Okay, so here you can refer to this diagram B, C, here A. Okay, so the vector OB represents this velocity of slider B, that is VB. Okay, the velocity of any point C on the connecting rod can be determined by the help of relation. The point C can be located on the velocity diagram. Join O with C. Vector OC represents the absolute velocity of point C with respect to O. Okay, from here, from this figure, the steps that has been written, it has been clear to all. Okay, next let us take an example. Okay, so in the mechanism as shown below, the crank O2A, this is the configuration diagram. Okay, O2A rotates at 600 rpm in the anti-clockwise direction. Okay, the length of link O2A is equal to 12 cm and link O1B is equal to 60 cm. Find angular velocity of link O1A, velocity of slider at B. Okay, so here you have seen this is the fixed point O2 and O1 is the slider. Okay, so this velocity is moving 30 degree in anti-clockwise direction, and here is the A is the crank. Okay, so you can see from here the velocity diagram how it has been drawn. So here you can see O1, O2 is the fixed point. So VC with respect to O1 is this vector, and VA with respect to O2 is this vector. Okay, at point A. So considering this point A, okay, which is this crank A on crank, so this A has been produced to C, and it is the velocity of C with respect to A. Okay, so solution, you can see N is given at 600 rpm. The velocity of A with respect to O2 is in the configuration diagram. Let us take a point C on the link O1B. The velocity diagram can be drawn as explained below. Okay, so step 1, O1 and O2 are fixed points as we have already seen in the configuration diagram. So they are taken a single point O1, O2 on the velocity diagram. Okay, the velocity of point A with respect to O2, that is VAO2, is equal to 7.53 meter per second, is drawn as vector O2A in some suitable scale perpendicular to O2A. Okay, so in some the suitable scale we draw this vector and it is measured as 7.53 meter per second. Step 2, the velocity of point C with respect to A, that is VCA, along the path of slider O1B. From A, draw a vector AC representing VCA along O1. This will contain point C. Okay. Next, step 3, the velocity of point C with respect to O1 is VCO1 and it will be perpendicular to O1A. Then, from O1, draw a vector O1C representing VCO1. This will intersect AC at point C. Okay, so here you can see this will intersect AC at point B. Okay, so step 4, locate the point B corresponding to point capital B such that O1B is equal to 5.55 meter per second by measurement and O1B is equal to VB01. Okay, so angular velocity of link O1A is equal to 9.25 radian per second in anti-clockwise direction. Okay, so we have got the angular velocity as 9.25 radian per second. So with this we have come to the end of this lecture. Thank you everyone.